Videocom by Odyssey and direct to Earth. Phoenix has landed. Phoenix has landed. Welcome to the northern plains of Mars.
Welcome and thanks for joining us this Sunday. Jubilation just moments ago at the Jet Propulsion Lab in Pasadena, California. A probe set to make the first studies of another planet's water reach the surface of Mars. NASA officials, as you saw, are now celebrating. The Phoenix spacecraft ended a nearly 10-month, 420-million-mile journey with a landing on the northern polar region of Mars at 7:53 p.m. Eastern Time. The probe is expected to spend 3 months analyzing soil and ice samples to determine if Mars was ever suitable to support life. And joining us, Kevin Shortt is the president of the Canadian Space Society. Kevin, thanks very much. I know you have a busy weekend and probably a busy few months now as this thing gets to work. Your feelings now that it's landed?
Well, it's certainly a big sigh of relief in the fact that we've landed on the surface of Mars, which is, now the farthest that we've managed to accomplish, because as people are aware now, I think that the previous polar lander was not this successful. So now we're in truly uncharted territories in the sense that we're on the northern hemisphere of Mars and we're getting ready to do the science. So it was a really excellent entry, descent, and landing period.
Now, we saw those very happy people at the Jet Propulsion Laboratory. What do they have to do now, and what kind of information will they be or hope to be getting back from this landing?
Well, certainly what they're going to be doing now is just like as any new family moving in. They're going to be unpacking the instrumentation. They're going to be powering up things. Certainly the next immediate things that are going to be happening in the timeline is unfurling the solar panels so that Phoenix can be starting to power itself up. Then they're going to be doing their checks a lot through the entry, descent, and landing. They've recorded a lot of the telemetry from the spacecraft, so they're going to be going over that, analyzing it, seeing if there may be any cause for concerns. But everything looks like it went by the numbers, and we're excited to be here.
Now, yesterday we were showing the amazing animation of what it was supposed to look like. As this thing was entering the atmosphere of Mars, what did happen?
Well, certainly the first few things that happens is you're starting to track it. There were 3 spacecraft already in orbit around Mars that were tracking Phoenix's entry into the atmosphere. So you're going to be seeing, as it entered into the atmosphere, you had huge amounts of heating. You're talking about thousands of degrees of Celsius on the exterior shell of the orbiter, and it's just going to be turning into this big massive fireball. Once the fireball dissipates and it slows down to several hundred kilometers per hour as opposed to several thousand, you're going to start looking at the heat shield dropping away, and then the parachute deploys, and these are all tenuous moments because there's nothing we can do about them. They're pre-programmed in the computer and they just happen within seconds of each other. And then once the parachute is deployed and it's a little more stable, then Phoenix drops away with a couple of minutes of a free fall, or a couple of seconds of free fall before you have a bunch of rockets. There's about 12 rockets that fire underneath the Phoenix lander to just gently lower it onto the surface of Mars.
Now that its 3 feet are firmly planted on Mars, what happens if this thing actually finds evidence of water?
Well, the scientists are going to be really digging into, okay, so how much water is there? What is the state of the water, whether it's frozen, whether it's mixed with other potential chemicals? And then they're just going to start teasing out more information. The big reason why we've landed in this particular part of Mars is because there's a huge signature for hydrogen, and a lot of the scientists have tied that signature to water. So really, just finding the water, just confirming that there is water in what scientists call ground truthing, they're going to, just finding that water is what's going to be the exciting point. And then from there, there's going to be all sorts of additional science for geologists and whatnot as they study the minerals and the rocks around the lander.
Hey, Kevin, when we started off the hour, we saw these amazing pictures of people practically doing cartwheels at the lab there. Talk a little bit about the work that they put into this. Why would they be so jubilant about this?
Well, certainly you're talking about a mission that started its development even before 2001. The previous mission that Phoenix was based on actually had its sort of tragic end in 2001. So you're talking about even years before that, that people had invested their times, had basically based their career on developing this lander. So to have it fail once, that's a huge hit to anybody's morale. It's your life's work, right? So now you have the opportunity. It's kind of a second chance to do this, and to know that you've done all the checks, you've made sure that everything was okay, and now you've actually succeeded in landing on the surface. I mean, that's a huge chance to celebrate, and this is one of the things that again, sitting in one of those computers, it always seems very anticlimactic when all you're watching for is these little cursors on the screen that just says, okay, and boom, you're on the surface of Mars. I mean, it's incredible.
Now, sometimes those cursors go blank, and missions have failed in the past. Why is there such a high failure rate to Mars?
Because you're talking about tremendously complicated systems, and when you're talking about the environment that you're going into and the trip that you have to go through to get there, I mean, you're talking about passing through a tremendous amount of space in between Earth and Mars, and there's all sorts of treacherous things to go through in that trip. And then, of course, in the last few minutes, I mean, those are the most treacherous, where you're dealing with such high temperatures and any potential flaws, and even if the orbiter doesn't quite enter the atmosphere in an optimal kind of way, that could cause the entire or the entire lander to burst into flames and crash onto the surface. So, and again, all of these things are not controllable by Earth, because as you may have heard, a lot of these events happen 10 minutes before we actually hear about them because of the communications delay. So we really have our hands tied when we're watching this, and we just keep our fingers crossed that everything happens the way it should.
In Genevieve's story, she made reference to the Canadian content, the Canadian devices that's on board. Tell us a little bit about it.
Well, certainly that's the part that's close to my heart. I've had the privilege of working on the Phoenix LiDAR, which is where that laser beam is coming from. So there's certainly exciting times, because as Canadians, and this Canadian technology is going to be providing information that we have never seen before on another planet, and in particular on Mars. So it's quite literal that in a few years we'll be able to say that turn on the 11 o'clock news and watch the weather here on Earth, and then here's a brief weather forecast from Mars. And these are the kinds of things that we as Canadians are excited about, because this is where the trend setting, the bleeding edge research is happening for us.
How long is this lander supposed to be hopping around, or whatever it's going to do on Mars?
Sure. The main mission is for 3 months, but everybody, all the scientists, they always hope that they can squeak out just a little bit more science, and certainly we'd hope that we could get some extra data and get a few more weeks, months. There are those out there that figure we would like to still be receiving data by the time Mars goes into winter and Phoenix is starting to get covered by snow.
All right, Kevin Shortt of the Canadian Space Society, thank you very much for joining us and guiding us through this.
My pleasure.